We're starting with these sine and cos of different expressions that are being added, and we're trying to get back to tan. So we're going to need to use addition formulae here. Right, so for the first one, essentially this is my A and this is my B. So I'm going to go straight for it. It's going to be sine of 2 theta times cos of pi over 4. We're working in radians here. It's just implied by the fact we've got pi's going on. Plus cos 2 theta sine pi over 4. And that is going to equal 3 times, now I need to use addition formula for cos, so I've got my A and the B there. It's going to be cos 2 theta cos pi over 4 minus sine 2 theta sine pi over 4. Now actually, sine pi over 4 is equal to cos pi over 4 because this is equivalent to 45 degrees and they're equal to 1 over root 2. So what I can do, I could write it out maybe, but I'm just going to basically divide through by this 1 over root 2. Do you know what? I'm going to backtrack. I think to just show enough working, I am going to write an extra step with this in. Okay, there we go. You might know the exact value or, you can put it in your calculator, it's fine, but this basically now going to cancel out. Okay, that is much better. We're well on our way now. So I'm going to get sine all on one side. I'm going to get 4 sine 2 theta on the left, and then minus the cos theta from both sides equals 2 cos 2 theta. Therefore, 2, if I divide through by the 2, wait, no, sorry, divide through by the 4, sine theta over cos, sorry, 2 theta, making mistakes here, but corrected it, that is going to equal a half. That means that tan 2 theta is equal to a half. Brilliant. We're then asked to find in third form the exact value of tan theta, given that theta is obtuse. So what that means is you can't just do inverse tan of a half on your calculator. If you try and do that, you're going to get, you're going to get some decimal number. We want the exact one. So actually, I really like this question. We've had to use addition formula for sine and cos. Now we're going to have to use double angle formula for tan. Set B equal to A, then tan of 2A is going to be tan A plus tan A, or 2 tan A, over 1 minus tan A times tan A. That's going to be tan squared A. So what we can do is say that a half is equal to 2 tan theta for us over 1 minus tan squared theta, and I've created an equation in terms of tans. Quite subtle, that bit. I'm going to multiply through by 1 minus tan squared theta first, I think. I could have multiplied through by 2. Do you know what? I'm going to do that. Multiply both sides by 2 to give 1 equals 4 tan theta. Note you just times the top by 4, not top and bottom, because otherwise you're not changing it. And then 1 minus tan squared theta is going to equal 4 tan theta. Okay, we've got ourselves a quadratic in terms of tan. So tan squared theta plus 4 tan theta minus 1 is equal to 0. And this isn't going to factorize. I mean, it's already talking about surds in the question. So I'm going to use a quadratic formula, which you often don't, write in full, but here we go. Minus b plus or minus b squared minus 4ac square rooted over 2a. So for us, minus 4 plus or minus 4 squared, 16, minus 4 times 1 times minus 1, so that's a plus 4 all over 2. This is going to become the square root of 20, which is the square root of 4 times the square root of 5, which is 2 root 5. So we get minus 2 plus root 5. Make sure you divide both by 2, or minus 2 minus root 5. Two solutions. However, in the question, they told us that theta was an obtuse angle, so we just need to see what impact that has. Okay, well, let's draw a graph of tan theta. Y equals tan theta. So for acute angles, tan theta is positive. That is from 0 to pi over 2, or 90. And then after that, it swaps around and becomes negative. This is the obtuse angle region. So the first one, root 5 is greater than root 4, so it's definitely going to be greater than 2. This is going to be greater than 0. Whereas this is definitely going to be less than 0. So I'm going to reject the first one. And tan theta is going to equal minus 2 minus root 5. That's a really good question because it's tested us on our addition formulae for sine and cos. And we've got an equation in terms of tan, and then it's done double angle formula for tan. It's led to a quadratic. I like it.